Good day, engineers. For today's video, let's dig in about semiconductor fundamentals. We will start the presentation discussing about electrical classifications of materials. Conductors. The conductor has more free electrons. It supports charge carrier flows. It supports the flow of electricity. It allows electric current to flow. Aside from that, it has a very low electrical resistance, and lastly it has less than 4 valence electrons. Insulators. The insulator has more than 4 valence electrons, and its characteristics are completely opposite to the conductor. Lastly, the semiconductors. Semiconductors have exactly 4 valence electrons. Its electrical characteristics are between conductors and insulators. Additionally, semiconductors has negative temperature coefficient characteristic. Here are the examples of semiconductors. For elementary semiconductors there are silicon and germanium. For compound semiconductors, there are gallium arsenide, aluminum arsenide and gallium phosphide. For the classification of semiconductors. First is the intrinsic semiconductor, which is pure and can be easily determined, as the number of its electrons is equal to its number of holes. Secondly, the extrinsic semiconductor. It is doped with impurities and categorized into two, N-type and P-type. Impurities have dopants that increase the electrical characteristics of semiconductors. The process is called doping. Another process that involves semiconductors is recombination, the release of energy. In this process, the band absorbs thermal energy, where the electrons from the conduction band travel its way back to the valence band.
When it comes to semiconductors, another topic to learn about is the material resistance. Semiconductors have resistance to the flow of electricity. For semiconductor material, its resistance can be evaluated as resistance is equal to resistivity in ohm centimeter, quantity length in centimeter over cross-sectional area in squared centimeters. Another important topic to be familiarized with is the bonding of atoms. 1. The ionic bond or electrovalent or electrostatic bond. This bond results from attractive forces between positive and negative ions, in short, transferring. Secondly, the metallic bond. It results from attractive forces between a group of positive ions and a sea of electrons that are free to move about among its ions. It is present in all metals. Lastly, the covalent bond. It results when atoms share their valence electrons with other atoms, in short, sharing. Additionally, here's the important information to jot down. The wider the energy gap, the harder the material can produce electrons. Conductors can produce electrons more easily than semiconductors. Ideally, in semiconductor crystal, at 0 Kelvin or absolute zero, there are no free electrons, and at room temperature, 300 Kelvin or 25 degrees Celsius, the valence electrons can acquire sufficient energy and become free as they move from valence band to the conduction band. Thank you for listening, engineers. This is the fundamental information about semiconductors.